Hi, I am Mia, and welcome to Solar Power School. Many people own a multimeter but are not sure how to use it. In this lesson, Joe will show you the 5 basic tests every beginner should know using the Klein Tools CL390. Let us head over to the workbench and get started.
Thanks, Mia. Today, I want to show you this. It is the Klein Tools CL390 multimeter. It is the meter I use, and it is the meter we will use throughout this lesson. That way, everyone can see the same dial positions, symbols, probe connections, and clamp that I am talking about. A meter helps us see what electricity is doing. It can tell us whether voltage is present, whether a wire or fuse has a complete path, how much resistance a part has, and how many amps are flowing through a wire. We are not going to cover every feature of this meter today. We are going to learn the 5 basic tests that will be the most useful to a beginner working with batteries, solar equipment, inverters, and household power. Before using any meter, inspect the meter and test leads, choose the correct setting, and know what you are testing before the probes touch anything.
The first use is measuring DC voltage. DC voltage is what we normally find at batteries, solar panels, charge controllers, and the battery side of an inverter. Plug the black test lead into COM. Plug the red test lead into the voltage and ohms jack. Turn the selector dial 1 click clockwise from off to the V position. The meter starts in AC voltage mode, so press the SEL button until the DC symbol appears on the display. Place the black probe on the negative terminal and the red probe on the positive terminal. The number on the display is the voltage between those 2 points. For example, a 12-volt battery might show 12.6 volts. If a minus sign appears, the probes are probably reversed. The number may still be useful, but the meter is telling you that the red probe is on negative and the black probe is on positive. Remember, voltage tells us the electrical pressure between 2 points. It does not tell us how much energy remains in the battery or how many amps the battery can supply. The second use is measuring AC voltage. AC voltage is what we normally find at household receptacles, inverter outputs, generators, and RV shore power connections. The test leads stay in the same jacks, black in COM and red in the voltage and ohms jack. Turn the selector dial 1 click clockwise from off to the V position. Confirm that the AC symbol is showing on the display. To test a standard 120-volt receptacle, place one probe in the hot slot and the other probe in the neutral slot. A working receptacle will normally read close to 120 volts. AC voltage can injure or kill you. Keep your fingers behind the guards on the probes. Do not touch the metal tips, and do not work inside an energized electrical panel unless you are qualified to do so. A 0 reading does not always mean the power is off. The meter may be on the wrong setting, a probe may not be making contact, or a test lead may be damaged. When a 0 reading matters for safety, test the meter on a known working source before and after checking the circuit.
The third use is checking continuity. Continuity simply means there is a complete path from one point to another. This is useful for checking a loose wire, a switch, a connection, or a fuse. First, turn off and disconnect all power. Never use the continuity setting on a live circuit. Leave the black lead in COM and the red lead in the voltage and ohms jack. Turn the selector dial to the orange ohms and continuity position. Use the SEL button to choose continuity mode. Touch the 2 probe tips together. The meter should beep. This quick check tells us the meter and leads can see a complete path. Now place one probe on each end of the disconnected wire or fuse. If the meter beeps and shows a very low number, the path is complete. If the meter does not beep and shows OL, the path is open or broken. A fuse can look good and still be blown inside. Removing it and checking it with the meter is better than guessing by looking at it.
The fourth use is measuring resistance. Resistance is how much something opposes the flow of electricity. It is measured in ohms. We may measure resistance when checking a resistor, heating element, sensor, coil, wire, or other disconnected part. Power must be turned off and disconnected before measuring resistance. Keep the black lead in COM and the red lead in the voltage and ohms jack. Turn the selector dial to the orange ohms position. If needed, press SEL until the ohms symbol appears on the display. Place one probe on each side of the part being tested. The meter will show the resistance between the probes. A very low number means there is little resistance.
OL normally means there is no complete path, or the resistance is higher than the meter can read on that range. The important point is that a resistance number does not tell the whole story by itself. You must compare it with what that part is supposed to measure. When possible, disconnect at least one side of the part before testing it. Other paths in the circuit can change the reading.
The fifth use is measuring current with the clamp. Current is the amount of electricity flowing through a wire. It is measured in amps. Unlike a basic multimeter that must be connected into the circuit, the CL390 can measure current by closing its clamp around one wire. For the small DC circuit shown here, turn the selector dial to the 40A position. Select DC current and zero the meter according to the CL390 instructions before taking the reading. The test leads are not needed for this measurement. Open the clamp and place only the red positive wire through the center opening. Close the clamp completely. The red wire must pass through the clamp. The clamp cannot simply lie on top of the wire. The black negative wire stays outside the clamp. If both the red and black wires are inside the clamp, their magnetic fields normally cancel each other. The meter may show close to zero even though current is flowing. The same rule applies to an AC power cord. The clamp must go around only one current-carrying conductor, not around the entire cord. The number on the display tells us how many amps are flowing through that one wire. Those are the 5 basic uses of the Klein Tools CL390. Use DC voltage to check batteries and solar equipment. Use AC voltage to check receptacles, generators, shore power, and inverter outputs. Use continuity to see whether a wire or fuse has a complete path. Use resistance to measure how much a disconnected part opposes current flow. Use the clamp to measure how many amps are flowing through one conductor. A meter does not find the problem for you. It gives you information that helps you find the problem.
Remember, the meter gives you information. You still need to select the correct setting, place the probes or clamp correctly, and understand what the reading means. Slow down, work safely, and practice these tests until they become familiar. If this lesson helped you, subscribe to Solar Power School and share it with someone who is learning. I am Mia, and we are all here to learn together.